Hello students, welcome to the new class. Today we are going to talk about chapter 5, which is arithmetic progression. In this particular session, what we're going to talk about is the introduction and some of the examples, and also we'll go through what exactly the arithmetic progression means. So this is one of the easiest chapter of fifth, which comes under fifth chapter, and it's one of the scoring chapter. So let's begin our session with the definition of what exactly arithmetic progression means. Arithmetic progression is also denoted as AP in short, and as the definition says, it's a sequence of numbers in order that the common difference of any two successive numbers is a constant value. So we know that what exactly is a sequence. Sequence is nothing but one followed by another one. It's called a sequential. So here we are talking about the sequence of numbers. So we can say that this is like, for example, 2, 4, 6, 8, 10 is a sequence of numbers. So what does it say? It says that it should have a common difference of any two successive numbers, which should be a constant. Then only it makes an arithmetic progression. Let's look into it. What exactly does it mean? So the common difference. For example, if we take 4 and 2, what is the common difference? 2. Difference is nothing but subtracting 4 minus 2. Let's try to explain here. For example, let's take another one, 6 minus 4. The difference is 2. And let's take another example, 8 minus 6. The difference is 2. So here we can see that the common difference we are getting as 2. Okay, let's try to understand with another example. So we have a sequence of numbers wherein 10, 20, 30, 40, 50, and it continues. So let's try to find the common difference here. 20 minus 10 is equal to 10. 30 minus 20 is equal to 10. And let's try another one. 40 minus 30 is equal to 10. So what did we do? We took 20 minus 10, then we took 30 minus 20, 40 minus 30. That's how we went to the sequence. So here, if you can see here, the common difference between the two successive numbers is constant, that is same. And also we denote the constant as D. Hope this is clear, students. Okay students, let's move to the next topic. Okay, so we saw something called a common difference, and it is denoted as D. We understand. So can this common difference be positive, negative, or 0? I have put some of the examples. Let's try to understand. So we have seen 4 minus 2 is 2, 8 minus 6 is 2. So we have seen the common difference here is 2. Let's take another example. 8 minus 10 is minus 2, 6 minus 8 is minus 2, 4 minus 6 is minus 2. So here the common difference is minus 2. Here we can see that the common difference can be negative. And we have also some of the sequence. There is also a sequence. It can have the similar numbers repeated, or it can have zeros repeated, 1, 2, 3, all can be repeated in the same pattern. So one of the examples we have seen is here it can have the sequence of numbers which are same. For example, 5 minus 5 will be 0, 5 minus 5 will be 0. So here the difference is 0. So hence we can say that the common difference for an arithmetic progression can be positive, it can be negative, and it can be 0. Hope this is clear. Yes students, let's now try to understand some of the terminologies being used in this particular chapter. So we know that this is a sequence of number. So instead of calling as a number, we call it as a term. If it is a first occurrence, it will say first term. If it is, for example, here we can say it as first term, we can say it as second term, and henceforth till it continues. It's nothing but the number which is being assigned, and it is called it as a term. We call it as a term. Okay. So here in our case, the first term is denoted as A in this particular chapter, arithmetic progression. So we know A is equal to 2, and we know common difference is also 2 here. So just you need to remember here is the element in the sequence, it call it as a term. For example, if I want to say what is the third term, 6. 6 is the third term. Hope this is clear, students. Having said that, we said arithmetic progression is of type of sequence numbers with a common difference. So we have a general form of representing an arithmetic progression, which can be represented as A plus D, A plus 2D, A plus 3D, henceforth it keeps increasing. So if you see here, it is first term is A, then it is A plus D with a difference, then A plus 2 with a difference. So this is how the sequence it will continue. So let's try to see whether this example fits in or not. So in this case we know A is equal to 2. Okay, so let's take an example. A is equal to 2 and difference is equal to 2. Okay, let's try to form with this particular formation of arithmetic progression. Here for A is equal to 2 comma 2 plus D is 2 plus 2, difference is 2 comma E is 2 plus 3, difference is 2, henceforth. So let's try to simplify it. 2 plus 2 is 4, 2 into 2 is 4, 4 plus 2 is 6, 3 2s are 6, 6 plus 2, 8, henceforth. If you see that, this is the arithmetic progression. So what you need to know is you need to understand here there is a general form of arithmetic progression called A plus D, A plus 2D, A plus 3D. So just want to make sure that this is clear with respect to it. Okay, so let's proceed to the next topic, students. Okay, students, we have seen an arithmetic progression. So there are two things which we see. There is a arithmetic progression which can be finite, and there is an arithmetic progression which can be infinite. Okay, so what exactly it means? As the definition says, finite. Finite means that you have the predefined sequence of numbers. Okay, infinite is something which is not ending, it keeps growing. Okay, so it keeps growing, so that is infinite. So just simply remember, something which does not have a stop or keeps growing, it's an infinite. Okay, and also the last term is referred as or denoted as L in the arithmetic progression. Hope this is clear. Okay, students, we have seen some of the arithmetic progressions. Now this is the important thing. So you need to know what exactly this particular formula is. So it's easy to remember. Okay, so if you want to know what is the nth term of an AP is arithmetic progression. We know how does it. For example, we said that any number is sequence in this particular sequence is called as term. For example, 4 term. Let's try to give an example. 2, 4, 6, 8, 10. And for example, if I want to know what is third term, okay, what is the third term? Okay, what do you need third term of this particular arithmetic progression? How will you come to know? Okay, so for example, if you have been given 2, 4, 6, and like this you have given a number and the last number has been given. So now if they want to know, instead of third they say 20th term. Okay, how will you identify? So in this particular case we can utilize this formula. Okay, so where an is equal to n is nothing but the term. So for example, if it is 6, here you can see this is third term, so an. We will see an example. A3 is equal to, we know what is A in this particular case is A is equal to 2. Okay, so let's try to identify the third term. Okay, and we know the difference is equal to 2. Okay, A is equal to 3. 2 plus n. What is n? 3 minus 1 into D, which is 2. Okay, let's try to simplify. 2 plus 2 into 2. Okay, 2 plus 4. 2 4s are 6. So from this we know the third term of this arithmetic progression is 6. Is this correct? We can see here. Okay, so if you want to identify the term x or nth term of an arithmetic progression, you can use this formula. Hope this is clear, students. Okay, students, now we have another important formula which to be used in this arithmetic progression, and believe me, these are the only two formulas which earlier which we have done, n term, and this is the one. So these are the one which we can which will be utilizing for doing your exercise examples, and these are the formulas which need to remember in this particular chapter. Okay, So let's try. So if you want to understand the sum of first n terms of an arithmetic progression, so if this is an arithmetic progression, if you want to know what is the sum of this, instead of keep counting, assume that it is of 100 sequential number. You cannot keep counting. So what you can do is you can utilize a formula to find the sum of this particular term. So let's try to put it in a practice. Okay, so n in this particular formula is the term, s is sum, n is the term where, as I said, a is the common, the first term, sorry, n which we can say the n term, and d is the difference. So let's try to simplify here and try to find what is a in this particular arithmetic progression. 5. What is the difference here? Difference is 10 minus 5 is 5, 15 minus 10 is 5. So the constant, the difference is constant, and we can say d as 5. Okay. Anything else we need to know? We know n. Yes, we know. We will try to find the sum of the fourth term. Okay, fourth term is nothing but the fourth element in the sequence. 1 2 3 4. Okay, so fourth sequence. So let's try to put this formula in practice. S4, sum of this fourth term, first fourth term of an arithmetic progression. Okay, 4 divided by 2 into a. What is the difference? What is the arithmetic progression? First term a. Okay, so let's not put this as a. Let's put it as the value 5. We have the first term plus n, we know 4 minus 1. What is the common difference? Common difference is 5. Okay, let's try to simplify. 4 divided by 2 is 2 here. Okay, 2 5s are 10 plus 4 minus 1 is 3. 3 into 5 is 15. Okay, 2 into 25. Okay, this sum is 50. Let's try to verify. So it says that the sum of the first 4 terms is 50. Okay, let's try to see the verified. Okay, with this particular. So let's try to add first 4 terms. 5, 10, 15, 20. These are the first 4 terms. Okay, 5, 5, 10, 1, 1, 2, 3, 4, 5, 50. Okay, so as you can see that the first 4 term of an arithmetic progression is 50. Hence, this is proof. Okay, students. So here till now we have understood the definition of an arithmetic progression, the common difference which can be positive, negative, or 0. We have seen the general form of an AP, how does an AP looks like, and we have seen what types of APs are there, finite, infinite, and also we have seen how to find the n term of an arithmetic progression, and we have seen lastly how to find the sum of the n term of an arithmetic progression. So just remember this when we are doing the exercises and the examples. This will be helpful, and we'll go through and we'll understand more in detail for the time being. So just remember this as a summary. Thank you.